So this is homework 3.6, number 4. So what do we know? We have a population of wolves in a sanctuary that's been growing by about 20 wolves per year, 20 wolves a year. And in my mind, put in the word per. So I don't like A there. I'm going to rewrite that as 20 wolves per year is the correct way to say that. Per means divide, so that is my slope. 20 over 1 wolves per year. In 2012, there were 415. Okay, so if the year is 2012, then the wolves equal 415. Okay. Create a linear equation for the number of wolves P for population, I guess, using the input variable N for number of years since 2012. Oh, okay. So like if I made a table here and I have years and wolves, I know in 2012, that's supposed to be a 2012, that's better. There were 415. Oh, wrong order. 415. And they're growing by 20 wolves per year. So that means then in 2013, there would be 435. And in 2014, add another 20, would that be 455? Now they don't want me to use the year from my variable. They want me to use the years since 2012. So that's N. So 2013, that would be 1 year later. 2014 would be 2 years later. 2012 would be 0 years later, right? We're in 2012. So that's kind of cool. This version of the variable here, N, years since 2012, means I know the starting point. So based on that one, I would just say, oh, P is 20 times the number of years that go by, starting with 415 in 2012. So that would be my first equation. So the benefit of starting in 2012 means, hey, that's my y-intercept. I don't have to do any work. I just write it down. Part B says, well, what if we pick T to be 2010? 2010 is a nicer number than 2012 because it ends in a 0, I guess. So let's think about that one. So for part B, I'm just kind of redo my table here. Years versus wolves. And they say for this variable T, I'll add another column on the left here. They want 2010 to be year 0. So then 2011 would be 1 year later and 2012 would be 2 years later, right? So notice that's different than what's going on over here. Here, 2012 is a 0 because we started in 2012, but here 2012 is a 2 because we're starting in 2010. Now, the wolves, bottom line is, it was in 2012, there were the 415, so the 415 has to go here. And just like before, I can say that in 2013, there's going to be 20 more. And in 2014, there's going to be 20 more still. So a couple ways to proceed. I could just count backwards by 20 and get there. Or I could use the procedure we've been using before. So I think I'll do it both ways just to kind of show they both work. Before, what I had said to do was, we know we want an equation like y equals mx plus b. Here we want the variables p and t. We're given m, so now we've got p equals 20t plus b, but in this part B here, we're not given the starting value, so we have to find it. And to do that, we just plug in a number we know, and I know that if t is 2, the wolves is 415. So then I could just put a 415 here, equals 20 times 2 plus b, and solve for b. 20 times 2 is 40. oops, not 14, 40. And then we would subtract that, right? Oh, so what is that going to give us? 475, is that right? Let's double check that over here. If we take 20 away, that's going to take us to 395. Yep. And if we take 20 again, that would be 375. So Gary messed up his subtraction. It should be 375. And I'm going to get a calculator just to make sure I did those right, since I messed up once. Desmos, where are you? Help me, Desmos. Okay, so we had 415 minus 40, 375. Okay, we're good now. So if we decide to use 2010 as our starting year, then our equation would look a little bit different. It would be P equals, we still have a slope of 20. Here we're using T, years since 2010. So that means we would have a starting point of 375 wolves, assuming it's that same 20 wolves per year change. So notice there's slightly different equations, same slope, different starting points, because we picked different years to start in. And then it said use both equations to figure out what's going on in 2018. Okay, well, let's see, 2018, that's 8 years after 2010. That's pretty straightforward. I would just say, hey, P equals 20 times 8 plus 375. We'll run that into a calculator and see what we get. Let's see, with this one over here, 2018 is how many years after 2012? Well, that's harder to think about. 6 years, right? I might have to double check on my calculator. I'm not very good with dates. I think it's 6. 20 times 6 plus 415. Do those give the same answer? All right, so part B, I'm going to take 20 times 8 plus that 375 starting point, 535 wolves. And then my first equation said take 20 times 6 plus that 415 wolves from 2012. Hey, same number. Whew. They should be. They ought to be the same number. Otherwise, something went wrong earlier. All right. We are kicking butt. What are the advantages of each way of defining the input variable? That is a good question. Well, let's look back at my notes, think about that. Okay, so the first way, let's get a highlighter out here. We were given the number of wolves in 2012. And if our variable was years after 2012, then that's our y-intercept. We're done. We don't have to do any extra work. So that was nice. Okay, I like that. Get an equation, almost no work. All right, what about the other way? Let's see, this other way, man, I had to do a bit of work to get that y-intercept. That was a lot of work. But I can easily look at 2018 and say, hey, that's 8 years after 2010. I had to think a little harder for how far 2018 is after 2012. Yeah, that's true. It's easier to think about years after 2010 than it is years after 2012. Okay. So here, if somebody says, you know, how many wolves are there going to be in 2022, I can more easily figure out how many years later that is to plug into my equation than the first way. But the first way, man, I didn't have to do any work. I just had the equation right away. Yeah, I don't know which one I like better. I guess for me, I like the first way because it was easier. But if other people are going to use this, the equation I came up with is easier to use for them because it's easier to think about how many years after 2010. So you guys can write up your own version of that idea.